Ready, Jonathan, we'll get going.
Absolutely. So, Karl,
Right.
thanks for the invitation.
No, pleasure. I'm really looking forward to this session. So welcome, everyone. Good afternoon. Today, we're going to be looking at some of the exciting changes taking place in the world of farm machinery and what that means for farming. My name's Karl Schneider. I'm the editor of Farmers Weekly. And with me is Jonathan Henry, the UK head of John Deere, which is the world's biggest farm machinery company. Now, when you think of farm machinery, probably the first thing that pops in your head is a tractor. That's the workforce of modern farming, and there's more than 2 million of them sold every year around the world. A big proportion are in the characteristic green and yellow of John Deere. But on modern farms, farmers use a host of other more specialised machines, combine harvesters, sprayers, and a bewildering variety of other attachments and things that connect to tractors to do specific tasks. So let's start with where we are now, Jonathan. When most people think about tractors, they probably don't realise how high tech they are already. Tell me a bit about some of the technology that goes into a leading edge modern tractor.
Yeah, sure, Karl. Thanks, and thanks again for the invitation to address this topic. Let's say so. Farm machinery has moved on significantly from that image, let's say, and often that's the image that's created by storybooks we buy our children, and of course those core factors are still there. You still need to turn power into motion, provide hydraulic systems to work, etc. But the big thing that's really changed in the last 15, 20 years is the amount of technology that's on machines, tractors, and other agricultural machines. And those layers of technology are highly varied in their way of thinking about them, but it's brought positioning systems, it's brought in telematics, it's brought in layers of sensors across the machine, and that technology pack, or technology stack as we call it, enables a whole bunch of things to be managed in a totally different way for end user customers to what was ever dreamed possible in the past.
When we spoke last week, I think you told me that there are more lines of software code in a modern tractor than there were in the space shuttle. Is that right?
That's true, actually. If you take one of our 8R tractors, which is our sort of flagship conventional form of machine, the current version of that tractor actually has more lines of software code than the original space shuttle. And of course, things have moved on there as well, but in terms of space. But yeah, that's not what necessarily one might think when you get stuck behind one on the road and want to know why it's not moving faster. So yeah, so these machines are, they are, mobile technology machines, and they're that's all necessary for machine optimization. But of course, it then provides a layer that we can connect to in a digital way, which was not possible before.
So many years ago, I was the editor of a magazine called Computer Weekly. And when I first stepped into a tractor cab, I felt like I was back in my Computer Weekly days. You're absolutely surrounded by screens. I mean, it really brings home to you how much technology there is. It sort of that you've got at your fingertips in the cab. You mentioned self-driving, and that's one example of an area where tractors are actually far ahead of sort of cars or other vehicles that maybe the public's more aware of. I mean, today, modern tractors, the advanced self-driving tractors, they can know where they are to within an accuracy of 5 centimeters.
Correct. People are very interested in what's happening for on-the-road vehicles, but actually, in the ag space, we've been selling what is effectively, self-driving machines for the last almost 20 years. In fact, the first auto-track system we put in the field in the UK was in 2001, and that was on a farm in Lincolnshire, and those were the early days where we could only follow straight paths, and it was only steering the vehicle from one side of the field to the next. But today, the precision of that ability to steer that vehicle has improved significantly over that time. Also, the ability to automate the headland turns, to generate path planning for the whole field and have that uploaded in the system before you even enter the field. All these technologies have developed in that time frame and are commercially available and commercially utilized today on farms up and down the country and around the world.
And of course, that's all. I mean, we're going to talk a bit about the future, and I think there are some really exciting things coming up. But I think it's worth reiterating that where we are now already is quite advanced, and that sort of very precise ability to know exactly where your self-driving tractor is in the field allows us to do things like precision farming, where you're applying the right amounts of chemicals to the right part of the field, which is already, improving productivity, but also reducing the environmental impact, because you're not having to spray areas that you don't need to spray.
Yeah, and there's a couple of things there I think that are worth noting. The first thing is that when the operator doesn't have the need to steer the vehicle anymore, that allows them to focus their attention on optimization, monitoring what's going on, whether that be the path ahead, or whether that be the performance of the job they're doing. And that means that they're better equipped to optimize what the job really is. But also, there's been massive steps in terms of automation of those jobs as well. Take sprayers, for example, whether that be a trailed crop sprayer or a self-propelled one. The introduction of section control initially, where sections of the boom can be shut off as you approach the headlands, so that you're not double spraying zones. And that just has taken another step forward in the last 18 months, really, now, with single nozzle control being truly commercially available. So it's not just subsections of the boom with multiple nozzles that are closing down. Each and every individual nozzle can be controlled and regulated. And not just from an on-off point of view, each and every nozzle can be controlled and regulated using pulse width modulation to control the dose rate. So that when the machine's turning, because the tip of the boom is the outside tip of the boom is traveling much faster than the inside tip, then those machines automatically regulate the flow rate on each and every nozzle. So that means that we're able to manage that dose rate absolutely precisely to the resolution of the nozzle, which typically is 50 centimeters on a typical crop sprayer that we use here in the UK. Big steps already commercially available.
I mean, that's a massive improvement on sort of bulk spraying whole areas of the field. So something else that I know we talked about when we spoke last week is not only does the technology sort of aid to do smart things within the cabin in the field, it allows the machinery to communicate back to the John Deere but with diagnostic information to help with maintenance, and also again to help with optimizing the machinery. Can you talk a bit about that?
I will, and I think that's an important area, because it's an area that automotive are actually quite interested right now, because the ag machinery business is way ahead of other sectors in terms of machine-to-machine communication. So before I even go to that layer of communicating off the machine, that the industry has put in place standard protocols to communicate between the tractor and implements. And those standard protocols means that there's a universal connectivity in that data flow. So an implement manufacturer if they comply with that standard, then they can simply plug into any tractor that also complies with that standard, and you have compatibility and intercompatibility of those data layers for machine control, but also for precision farming. And that's something where cars are going to need to do that to enable autonomous vehicle use. Just you can realize so much by the vehicle doing its own thing as its individual self, but you can realize a lot more when you actually have vehicle-to-vehicle communication, and that's somewhere where ag already has those types of standards in place, and not just from the vehicle to implement, also from vehicle to vehicle in the field. So, for example, a combine, for example, unloading grain on the go. Because typically at these high productivity rates we see today, unloading can be as much as 25-30% of the actual operating time. So actually having the combine take over the steering and the speed control of the tractor alongside that has the grain cart attached to it, that means that speed changes on the combine can automatically be communicated to the tractor, and the tractor becomes a slave to the combine. So that's another example of technology that exists today commercially and is being utilized by farmers around the world. But then if we go to what you really asked, which was about actually communicating off board, and that's where telematics, we see telematics now deployed more and more in cars. It started in high-end cars, and it's gradually coming down the price point. If you take large ag machines, then many of those have had telematics in them for more than a decade now. And in fact, in John Deere, in the large ag machines that we've had, so what we would call mid-tractors through to large tractors, combines, forage harvesters, they've had telematics in base equipment since 2011. So what that layer does is that allows all sorts of things to happen, right? So that allows us to then remotely monitor those machines in terms of their performance for uptime. It allows us to put in place what we call expert alerts, which is where if we get certain sequence of signals from sensors, we can predict in advance that a failure could be about to occur, and actually be able to schedule a repair or an adjustment to that machine before it even goes down. So we have situations with technicians calling customers to say, we need to visit your machine, we need to change a component on that machine or a sensor on that machine, and doing that proactively, doing that in a downtime period, and actually being able to execute that with zero downtime to that customer.
People who aren't familiar with farming perhaps won't appreciate how important something like that is. But if you're mid-harvest, then often you only get a narrow window when you can get out on the field to harvest. If your machinery breaks down at that point, you're in real trouble. So being able to predict, look, this is going to fail, let's fix it now before it fails, is a real advantage.
Yeah, and it's, farm machinery, it's there and it's typically used for a short number of weeks, or in some cases even days per year. And the timing is the single biggest factor in crop production, whether that be timing of planting a seed, whether that be timing of applying a crop protection product or a nutrient, or timing when it comes to harvesting. And of course, we're operating, unlike those vertical farming people you talked to earlier, who have the luxury of having a controlled environment, then farmers are operating in an uncontrolled environment. And of course, the weather is always the gamble. And that's the bit, is that timing can make the difference between whether that year's harvest was profitable or not. And so it's a key component is to be able to maximize that availability of those machines to do the job they're intended to do, and keep them running when they need to run, and then utilize the downtime for any maintenance or any repairs that are necessary wherever possible. The other piece that layer of technology does is it allows dealers that are supporting customers, or even big farms will do this themselves, where they maybe have they have a scale that they can afford someone to optimize their machines on farm. Then it allows them to actually have someone remotely monitoring those machines, making sure they're fully optimized, and choosing whether that be for maximum productivity, maximum quality, whatever that output, highest output characteristic is that's desired. And then for more medium-sized farms and smaller farms, then dealers can provide that service, and their specialists can connect to machines remotely, identify optimization opportunities, and not just post-event, but actually in real time during the event, during that job that's being done, whether that be, again, planting, crop protection, nutrient application, or harvesting.
One more thing before we sort of start looking into the future. Again, I think probably most people don't appreciate what a marvelous bit of kit a modern combine harvester is. I've heard it described as a factory on wheels. Can you just say a little bit about what goes on in a modern combine?
Right. So, at a basic level, what a combine does is very similar, and a lot of the core principles of the technology at that basic functional level are the same as the original early machines. We're cutting a crop, we're feeding that crop, then we got to separate the grain from the other material in a threshing system. Then we got to separate that loose grain now from the rest of the material, and then clean the material, handle that crop, get it into a point where it's in a storage hopper, and offload that to a logistics network. And then at the same time, very often we're also processing that material other than grain, redistributing that back in an even, consistent way back to the ground, so that the next job coming along, which could be a tillage operation or it could be a direct seeding operation, so that that's then optimized. And so it's like a mobile factory, what's going on there. And of course, although those basic principles of operation haven't changed much, they've been scaled up in terms of size and productivity. In the latest machines today, winter wheat is our biggest crop in the UK, and the latest machines today can process well in excess of 100 tons an hour, and that's a phenomenal amount of capability. But as well as that, those machines now are completely covered in sensors, and those sensors are for machine health. Those sensors are for machine or systems operational understanding, but they're also for sensing characteristics of the job. And that could be cameras, stereo cameras for monitoring the grain quality, and that can be used for machine optimization, so the operator can see that live from the cab. But also we have systems now that also are able to interpret that using AI to understand what that machine is doing and automate the machine settings, so that the operator chooses what their outcome characteristic is, whether that's highest productivity, whether that's lowest grain damage, whether that's highest grain quality, whatever metric that is that they desire, and then the machine will automatically adjust itself for those characteristics. So all of that's happening, and then at the same time, that data is also recording the yield that's coming off that specific part of the field, and a technology that's coming in the very near future is to not just be able to do that at the scale or the resolution of the header width, to also to be able to do that at sub-header width resolution, so that the vision of true precision agriculture, and ultimately we see that at the level of a single plant, that's the journey we're on. We're heading towards that. So it's a step function change away from those early open station machines in terms of what that mobile factory is doing.
So that leads us really nicely onto sort of looking at the future. So if we look ahead 10 years, if I was standing on a modern sort of leading edge farm in 10 years time, give me some highlights of what would I see there that might capture my imagination a bit.
I think that's a really good question, Karl, because I believe we're actually at a hinge point right now as to where technology, the digital transformation that's about to happen, we're right on the cusp of it. Precision agriculture promised a whole load of benefits 30 years ago, when really it was first went from being a concept to being realized, and yield monitors and yield mapping were first launched on combines. Now, that economic headroom that was identified 30 years ago, the majority of that is still sitting out there untapped by farmers, even though many of them are, and a very high percentage of them have invested in the technology to capture that data. And there are improvements that have been made in the back of that, but in reality, most of that is still untapped profit opportunity or yield opportunity or quality opportunity, depending on what your primary goal is. And the proliferation of data and the rate of data capture that's going on right now is what is the enabling component. That, in combination with advanced tools that can process that information, turn it into information that's of benefit to the grower and to the grower's expert advisors, we are at I believe we're at a turning point where that is going to unlock in a way that was originally dreamt possible 30 years ago from precision farming, but also it's going to enable things that weren't even thought about then, especially things in the whole sustainability space. As well as that, there's also potential for value chains that don't exist today to be unlocked with that data. Things like, what was the energy requirement to produce that kilogram of grain? What was the the other inputs that went into that producing of that crop. If we're able to trace that and track that from the field or from the seed and the other nutrients going in all the way through to the end product, then that opens up potential for new revenue streams that didn't exist or don't exist today even to be there in the future. And I truly believe in 10 years that we'll be living in that world.
Yeah. So to get, you mentioned how important data is, and I guess to get the benefits, you need a number of things all to come together, which is perhaps why it's taken so long to go from talking about it to actually delivering the benefit. You need to have the data, so that's sensors or whatever to capture the data. You then need to have the tools to analyze it. And then finally, you need to have the technology to make use of that data to do stuff in a very precise way. Now, one area I know that John Deere has been looking at is something called See and Spray, where you've got cameras on individual nozzles. Can you tell me a bit about that?
Sure. So, this will be one of the step function changes in how we farm. Is that today, Karl, for those you know this, but today we generally apply herbicides and other crop protection products on a blanket basis. We have a certain level of that of a pest in the field, and we go out and we treat it with a single dose rate at a field level. And with stereo camera technology, but it's not the hardware, it's the software processing behind that. Then it will be possible in the future to actually look at that crop as we drive through the crop, make a process decision as to whether that plant at an individual plant level is the desired plant or an undesired plant, and then make a decision in real time as to what to treat that plant with, whether that be a single dose of that active ingredient, whether that be a controlled dose of that crop protection product. That sort of possibility will be unlocked in the future. In fact, Deere has invested in one of those. There's a lot of startups in the world operating in this space, right? And 18 months ago, Deere purchased one of those, a company called Blue River in California, because we wanted to make sure that that technology could come forward quickly and be accelerated, because we truly see a lot of value there for growers around the world in terms of economic value, but we also see a lot of value there for the planet. And if we can get that technology up and functioning, then we believe that a machinery company like John Deere is best positioned to be bringing that to market to customers, because the types of things that are necessary to get that in market and functioning for farmers align very heavily with the types of services that John Deere and its dealers do today.
Okay,
is in 10 years' time, we believe See and Spray will be here and functioning.
And just to make sure people understand, I mean, that is a really impressive thing to do. You're talking about in real time going over a crop and having cameras looking at individual plants and saying that needs some, that doesn't, that needs a bit more, that one doesn't, and then the sprayer applying that as it goes over the plants. I mean, I can imagine the processing technology you need to do that is quite complex.
Yeah, and it's most likely that processing will be done off board, so therefore it will need data communication to the machine live stream at rates that aren't available with commercial networks. So 5G will be a big key component to that, but also we're looking at areas where 5G, or just take phone signals today. If you're close to a major road network, then you probably have pretty good cell phone coverage across your farm, but many of the farms in the productive parts of the world are more remote than that. So we expect that this will also need local radio networks set up to cover farms in a way that isn't there today to truly enable this. But again, that's where we're looking at the whole piece there, let's say, and what's required to do that. But you're right, it does require very high levels of processing capacity, and if we think the economics of putting that on every machine that's going through the field are unlikely to map out. So those types of communication are going to be really important in the future.
I'm going to come on in a minute to ask you about some of the barriers, right? And I know that access to the communication bandwidth to be able to communicate with the machines is one area that we still need a bit of improvement in. But I want to come on to some of the other areas where there's some exciting developments coming. People talk about electric tractors, and I know there are limits to how far you can go with in terms of the power density. You know, some of these big arable tractors need to be able to pull pretty heavy loads and deliver a lot of power. That at the moment it's a real struggle to do electrically. But I think you're already working on electric transmissions and looking at applying electric drive to some of the smaller tractors in the not too distant future.
Yeah, so electric is a big topic, and it's one that's heavily in focus at the moment, especially as the UK has just accelerated the rate that automotive is going to have to get there, and it's something that we've been working on for some years. So first of all, we see electric drives within vehicles becoming more and more important. We already use electric drives and have done for over 15 years in our golf business. If you buy a greens mower, for example, we offer an electric drive instead of hydraulics there, and we have done. And the driver for that is two things. One is efficiency of that drive, but also the fact that you don't have any hydraulic leaks when you use that system. But if you look at electric drives and its application in agriculture, then it's unlikely to replace hydraulics for linear motion. Hydraulics are very, very efficient in that space, but for rotary motion, then electric drives offer efficiency opportunities and also control and precision opportunities. So yes, we will see more electric drives come into our machines. In fact, a year ago now at Agritechnica, we did display an e-auto power transmission, and that is basically the hydrostatic components in that have been replaced with electric drives, electric generators, and electric motors, and that's on its way to market. In fact, that transmission won a gold medal at Agritechnica, which means it needs to be in market within 2 years. So that's coming close. However, at least for large ag, I just want to go back. So if we use electric as a primary energy source, then there's going to be lots of opportunities for that in smaller machines, in our turf machines, and in small ag machines where the duty cycle is lower. However, for large ag machines, then the power density of diesel as an energy source is extremely competitive, and at the current the current level of technology that's available in batteries, then they're not competitive in that space, and it'll be some time before that becomes the case. So we see electric coming into large ag as a drive mechanism, replacing hydrostatics for efficiency and machine control and precision. But in the 10 years that you were just talking about, then I anticipate that for those big machines, then diesel will continue to be the primary source of energy on board. But there's other spaces being explored there, but that's what we expect at this time.
Another area, looking ahead, another area where I know there's been a lot of excitement is in drones, and a lot of farmers have bought drones. I'm not sure how many of them are using them to make a real impact on their farm rather than as toys. But where do drones fit in John Deere's vision of the future?
So again, back at Agritechnica last year, we displayed a number of prototype systems that we're exploring and working with. One is a large drone project that we were working with, which was working on using that system to spray very, very steep, high-value crops where it wasn't possible to use tractors. The slopes were so steep for that, and that was allowing crop protection systems to be or products to be applied in those environments. Another area that we're working on here was autonomous drones. This was a swarm system where you could take if you think about it as a beehive or a drone hive, you mount it on a transport platform, you tow it into a certain zone in your farm, and then that drone hive would have multiple drones in it. They would actually fly out from the hive, and they could go and do scouting on the crops. If they identify they can identify pests or scan the quality of those crops, scan the growth rates of those crops, communicate that back to other drones that are in the same hive, and then those drones could go out and do active treatments and apply product or apply specific treatments to those individual plants. So it's still a concept, but it's a working prototype. There's still a lot of regulatory space around drones that is still to be clarified in that way, because these would be drones operating, autonomously. But it's an interesting space to explore and gain insights about the system integration and what that would take to make that possible. So that's probably a bit further out, but I think there's all sorts of potential opportunities in that space, and also potentially very sustainable, again, by plant by plant monitoring and plant by plant treatment would also become feasible with that sort of system.
That is really an exciting vision. We're actually at the end of our time, but I want to quickly sort of pick up on a couple of questions that we've had in while the session's been running, and the first one sort of follows on from what you were talking about in terms of autonomous drones. What is the scope for giving full autonomy to this farm machinery? So whether it's tractors or robots or drones, so you're not having an operator controlling them or even controlling a group of them, but that they're running on their own using maybe AI to determine what they do.
Yeah, so the technology to do that exists today. That capability, ourselves and many of our competitors have that technology on the shelf today. To actually bring that to market, there's two things. One is the economics of it, and there's layers which are already deployed, like I talked about, like the machine control layers, which basically are there today and have been for many years in this industry. But when it comes to perception, because you got to remember that most broadacre farming is happening in an uncontrolled environment where you've got public access, even whether they're supposed to be there or not. You've got to assume that that could be there. Other foreign objects or other objects that that shouldn't be there but can be there, and there's also wildlife access. And so those perception systems that are able to manage that, the technology, as I say, exists for that, but they're still at a cost point that's way above an operator, and that will change over time. Some of how that changes will be determined by what automotive end up truly doing, because there's extra layers we believe are necessary in agriculture than what are required potentially on road, but that's not known yet as to how that will truly evolve. There are certain ways, if that does evolve, then that will accelerate the reduction in cost of those systems, and that will bring it to agriculture quicker. If it goes a different way, then it could take a bit longer for that cost piece to come into a point where it crosses the break even for return on investment for a farmer. So it will come. There's no question about that, and it's a question of when, and that cost piece, and then the other piece is the regulatory framework. Because if you call your insurance company up today, Karl, and say, I'm just taking delivery of my new autonomous combine harvester tomorrow, can you just slip it on my insurance, my fleet insurance for me? You might say, well, just hold on a minute, we need to give you a call back. And so it needs a regulatory space for insurance markets to operate in, and that still hasn't evolved yet, and it's being talked about, it's being worked on, but it's not there yet, and that will be necessary. So I think you'll see these systems come into areas where operators are most expensive first. That's where it will be seen and adopted first, and some of those areas are also some of the most remote production areas of the world, where they're competing, perhaps agriculture is competing with mining and other industries for labor. And that's where we anticipate that will happen. Will it be in 10 years? Possibly. But again, it's not technology limited. It'll be return on investment, and regulatory framework will determine that timeline. In the meantime, because when we get there, we don't need to just get that perception system working. All of those other machine monitoring things that the operator is doing today, those also need to be in place. So we're investing in those already now. We call it a journey of automation to autonomy, and where those packages of automation make value for productivity or quality enhancement of the job being done, we're already going to bring those to market in advance of that, because in the end we will need those to truly realize full autonomous machines. But it's an exciting time, and as I say, an exciting decade ahead of us in the farm machinery space.
So just to finish off, and this is again responding to a question, if someone's been inspired by some of the stuff they've heard, and it is, you know, for someone who's interested in science and technology, there's some really interesting stuff that's going to happen over the next few years. What sort of roles are there in an organisation like yours? What sort of people will you be recruiting over the next few years, and what career opportunities are there?
Yeah, that's an interesting topic, because if you look at where John Deere, where most of our factories and engineering centres are, they're not always in the big metropolitan hubs. They're often in more remote zones. And actually, we've just opened an office now in Silicon Valley, and that's for that exact reason, is to attract the type of talent we need. So, John Deere still needs, core engineers, in terms of, because we're not going to sell this technology without the machines, right? We still need engineers that can develop drivetrains, engineers that can develop separator systems, other vehicle systems. But in addition to that, we need more and more data scientists. We need more people from that space of understanding in terms of what this technology can do and unlock that. So that's a change that's already started, and it's one that's accelerating as we speak. So absolutely, in the future we will need a lot more highly specialized capabilities and skill sets in our people, and the way we're opening our talent hopper up is intentional to attract that type of skill set. So, because a lot of this, the science behind this, most of that exists. It's about taking that science and turning it into an application and into a product and service that can be then utilized by end user farmers. And we see that as the role we have to play, and we intend to do the very best job there that we can.
We're over time, so we're gonna have to draw it to a close there. But Jonathan Henry, thank you so much for that. I think it's a really exciting few years coming for this whole sector, and technology is going to play a massive part in the transformation of farming over the next few years. So I look forward to seeing that. Thank you to everyone who joined in the discussion. I think we had over 180 people earlier on in the chat, and big thanks to Jonathan Henry for sharing his views today. Thank you.
Thanks, Karl.
Oh, and don't forget, if you want to take this further, go to the John Deere virtual room, and I think you can see some more stuff going on in the virtual room.
Absolutely.
Okay, bye-bye, everyone.
Bye now.